Welcome everybody to STEM Education Academy. Today we're going to do some problem solving and learn about problem solving techniques using the Bernoulli probability formula. So this is the equation, this is the formula, and this formula deals in cases where we have an experiment that has a certain amount of trials and there are only two possible outcomes, success and it might be something that has more possible outcome in its sample space, but yet if it's a die, for example, and the possible outcomes are 1, 2, 3, 4, 5, and 6, and we are looking for 2 as a success, so everything else counts as failure. So again, n is the number of trials, x is the number of successes, p is the probability of success, and q is the probability of failure or the probability of not success. This is why it's enough to know p in order to be able to find the value of q, which is just 1 minus p. Or the opposite, if we know q, we know the value of p, which is 1 minus q, over x factorial times n minus x factorial. And if you take this and substitute, you will just get the same equation. You can see here the p to the power of x right here, and the q to the power of n minus x right here. All the rest is just the expression that comes before this product. So this is the way that you use it if you want to calculate it manually, and this is the way you use it if you want to use the calculator. We're going to see both ways. So let's start with an example of the problem. You roll a fair die 6 times. What is the probability that it will land on 6 up, which means the die will show the number 6? Number 1 exactly once, number 2 exactly twice, number 3 exactly 3 times, number 4 at least 3 times, and number 5 at most 3 times. So we're going to start. There are actually 5 problems here, but they're based on the same introduction. So let's see what we can write out of the givens. We have a fair die and we roll it 6 times, which means n equals 6. We have 6 trials. Now, what is the probability that it will land on 6? So landing on 6, this is our success. And we're going to write the probability of our success as 1 out of 6. Because there are 6 possible outcomes for a die, it is the sample space will be 1, 2, 3, 4, 5, or 6. So we have 6 possible outcomes, but 1 desirable outcome, which is 6. So 1 desirable outcome over 6 possible outcomes, the probability for 6 is 1/6. Now, what is the probability that it will not land on 6? It's all the rest. So if everyone here is 1 out of 6, then if we add up all these, we will get 5 out of 6. So this one will be 5 out of 6. And notice that if we do 1 minus p, which is 1 minus 1 out of 6, we also get 5 out of 6. So it is enough to know the probability for success in order to calculate the probability for failure. It's just 1 minus the probability of success, and this is our q. Now we're left with x, but x is going to change between these options. These parts 1 through 5, we're going to have different x. So exactly once. In number 1, x, we have 1 success, so x equals 1. Let's write down the equation. P of 1 success exactly equals to n factorial over x factorial times n minus x factorial, and this times p to the power of x, and then q to the power of n minus x. So this is our equation, and let's plug in the numbers. So first we have n factorial, and this is divided by x is 1, so we have 1 factorial times 6 minus 1, because it's n minus x. N is 6, x is 1, n minus x factorial. We're done with this expression. Now p equals to 1/6, 1 over 6. I'm going to write it, and don't forget parentheses, it's an important part for the calculator, to the power of x, which is to the power of 1, times q, which is 5 over 6, to the power of n minus x, which is n minus x, 6 minus 1. Okay, now I'm going to show you the manual calculations, but then I'll show you how to do everything using the calculator and using the option of C or NCX. Okay, so but first we will do the manual calculations. Maybe you'll appreciate the calculator later. This manual calculation is actually simple, as much as it looks complicated with all these factorials here, but it's going to be simple. And why is it simple? 6 factorial equals to 6 times 5 times 4 times 3 times 2 times 1. 1 factorial just equals to 1. And 6 minus 1 is 5 factorial, which equals 5 times 4 times 3 times 2 times 1. So all this expression, the one is not important, all this expression here is being reduced or canceled out, and we're left with 6. So let me write it down here, 6 times. Now, 1/6 to the power of 1 is just 1/6. And 6 times 1/6 is 1. So we're going to continue to this part, 5 over 6 to the power of 5. Basically, all we have to calculate is this part, because these 6 and these 6 cancel out, and we're left with 5 over 6 to the power of 5. So now I'm going to use the calculator. You can use either scientific or graphing calculator. I'm going to demonstrate on TI-84, but I believe that every TI, older or newer, have the same options. So 5 divided, sorry, let's turn it on. Even a virtual calculator needs to be turned on. There we go. So 5 divided by 6, and parentheses here is very important, and I will show you why after I calculate this, to the power of 5. And the answer is 0.4018. I'm going to round to the nearest hundredth, so this equals to 0.40. And after I round, there is nothing else left. This one is being rounded to this 0 remains 0. Now, what happens if I don't use parentheses? 5 divided by 6 to the power of 5. Then in this case, it's just since we have order of operations, 6 is going to raise to the power of 5 first, and then the 5 is going to be divided by this result. We're going to get a very low number here. You see 6 times 4, 3 times 10 to the negative 4. So the number here doesn't matter if it's small, large, just the wrong number. So make sure that when you have a fraction to the power, it must be entered with parentheses to the calculator. Okay, let's clear that. And now I'm going to show you how to use the shorter version. So in the shorter version, we will write it as, instead of this expression, we'll have NCX, but if we have to plug in the numbers, then we have 6 trials. C is just a symbol. X is 1 success. And then we have P, which is 1/6 to the power of 1. And then we have 5/6 to the power of 5. In this case, we already know from the previous solution that these two cancel out and I only have to calculate these. But the point of this part is just to show you how to use the calculator. So at this point, I can start punching everything directly to the calculator. To get to this symbol, you have to press Math, and then you're going to have a tab menu up here. You have to choose probabilities. I'm going to move to the right and choose, you see number 3 is NCR. Instead of X, they're using R here, so I'm going to choose number 3. And now it asks me to put the two numbers to the left and to the right. So we know that we have 6 here. I'm using the arrow to move to the right. And I have 1 here. And I'm using the arrow to move out of that subscript mode. And now I'm going to put 1/6 to the power of 1 times 5/6. Sorry. Let's go back and delete. I forgot an essential key. Okay, to the power of 1. Now I have to press on the right arrow to move out of the exponent, and then times 5 divided by 6 and to the power of 5. And I press enter, and I get the same result as I got right here, rounded to the nearest hundred. Another way to plug this in, if you have a version, a TI version older than TI 84 plus, TI 83 or so, so you want to first type in the number 6, then you go to Math and choose Probability and choose number 3. You see now that the 6 is already here and it expects the next number, which is 1. So first you type the left subscript, then you go to the Math, Probability, NCR, and then you type the second number, and never forget to get out of the subscript mode by pressing on the right arrow. So this is the solution for number 1. Let's solve number 2. In number 2, x equals 2. We have 2 successes, exactly 2 successes. And I'm going to use the shorter version of the equation. So we have P of 2 equals 6, choose 2. And here we have 1/6 to the power of x. P is to the power of x. And Q, I'm sorry, I will not write Q, it is 5/6. And also x here is 2, so I'm going to erase that and substitute 2. And 5/6 to the power of n minus x, which is 6 minus 2, which is 4. Okay, all we have to do now is to use the calculator. I'm going to clear, and now 6, Math, Probability, number 3, and clear. 6, Math, Probability, number 3, and then 2. Get out of the subscript, 1/6 in parentheses, 1 divided by 6 to the power of 2 times times 5 divided by 6 to the power of 4, and enter. And the answer is 0.2009, again rounded to the nearest hundredth. I'm going to get 0.20. It's important when I say round to the nearest hundredth, it's important to show the second decimal place, the hundredth digit, because then you know that it is zero, but it's rounded to a hundredth, which means that number was less than 5 here. So if I just write 0.2, yes, it has the same quantity value, but if I just write 0.2, you don't know that it's rounded to a hundredth. Okay, let's do x equals 3, which is number 3. That's the only difference. X equals 3, so we have probability of exactly 3 times 6 will be 6, choose 3. 1/6 to the power of x, which is 3. 5/6 to the power of n minus x, which is 6 minus 3, which is again 3. Okay, let's do the math. Calculator, clear. So again, 6 and math. Probability, 3 and 3 again. 1/6 to the power of 3. Get out of the power mode. Then parentheses, 5/6 and parentheses to the power of 3, and enter. And the answer is 0.05. Okay, that's rounded to the nearest hundredth. So 0.05. And you can see that there is more than that, but if I round it by the 3, so it's still 0.05. Okay, so we have probability of exactly 1, exactly 2, and exactly 3. Now, question number 4 is, what is the probability that we will have at least 3 times out of the 6 trials? That's the meaning, at least 3 times out of the 6 trials, the die will show us 6, the result 6. 3 times out of the 6 trial, at least 3 times. So what does it mean at least 3 times? We might see 1 time 6, 2 times 6, 3 times 6, 4 times 6, 5 results of 6, or 6 results of 6. Each one of these is possible. We cannot see, we also might see no 6 at all, right? We might see something else. So it's not necessarily that we will have 6 at all. So I also add 0. So at least 3 times. Where is the at least 3 times? So at least 3 times means 3 times, 4 times, 5 times, or 6 times. This is at least 3 times. So now we will have to calculate what is the probability of each one of these. We already calculated the 3. We know that the 3 is 5%. Then we have to do the equation 3 more times. And if we do the equation 3 more times, it will take us 3 times the amount of time that we used before. Use the calculator again 3 times. Remember that we already calculated 2 and 3. We didn't calculate 0. So now we have to do some kind of trick. It's either you're going to calculate 4, 5, and 6, and then just add all of them. Why add? Because it's 3, or 4, or 5, or 6. It's one out of these. This or this or this or this. And or turns to plus. So it's either you're going to calculate P3, which we have the number for that, plus P4, plus P5, and plus P6, and add them all, or you say it's the same as the probability of this will not happen. Okay, so let's calculate what is the probability that this will happen, which means it will show us 0 or 1 or 2. We already calculated 1 and 2, so let's calculate P0, which means it will never show 6. We try 3 times, we try 6 times, and it never lands on 6. It's a possibility. So let's try that. We're using the same equation. So we have 6 trials, 0 successes. And then we have 1/6 to the power of x, and x in our case is 0, times 5/6 to the power of n minus x, which is n is 6. Just to remind you, I'll scroll up. N is 6, n minus x. 6 minus 0, which is 6. I will write here 6 minus 0, so you know where it's coming from, the 6. So first, any number to the power of 0 is 1. I can ignore that. I will show you how to calculate this again in the calculator, and then we also do 5/6 to the power of 6. So let's use the calculator now. So once again, I'm going to do 6 math and probability 3 and clear. Let me clear that again. 6 math. That right arrow, the virtual one, just sometimes skips an option or just doesn't move. So now 3, and then I'm going to put the number 0 and move to the right, and now we have 5/6 to the power of 6. And here we have rounded to the nearest hundred, 0.33. Okay, so now we know P0, P1, and P2, and let's add them. P0 or P1 or P2. So here we have 0.33 plus P1 was 0.40 and P2 was 0.20. That's the P2, and the P1 was a little bit higher here. That's P1. And if we add all these numbers, we get that P1 plus P2 plus P0 equals 0.6, 0.93, 0.93. Which means there is 93% that it will show 0, 1, or 2. Now we want at least 3, which means we want not of 0, 1, or 2, or not 0.93, which is 1 minus 0.93, which is 0.07. Okay, so this is our answer. And the last question is, what is the probability? What is the probability that it will show 6 at most 3 times? It will show 6 at most 3 times. So in this case, at most means nothing, or 1, or 2, or 3. This is at most 3 times. At most means we don't want more than 3. So we don't want 5, 4, 5, or 6. All we have to do here is just add these numbers, and here we said that we have 0.33, 0.33 plus 0.40 plus 0.20 plus we had 3 times. I think we had 0.505. Yeah, 0.05 right here. And we're getting to 0.98, 73, 93, 98, 0.98. We see that it's very high probability, 0.98, that it will show a number. It will show the number 6 at most 3 times. It's very high probability. It means that P5 and P6 have to be very, very small numbers. Okay, let's, for example, calculate P6. So P6 will be, I'm not going to use the calculator for most of the part of the calculations. I'm just going to tell you the numbers. You can check it with the calculator. So we have 6C6 because X is 6 now and N is 6 times 1/6 to the power of 6 times 5/6 to the power, if you remember, of N minus X, but N minus X here is 0. So let me tell you something. This is 1, this is 1. So we have 1/6 to the power of 6. This should be a very, very small number. So let's just try it. 1/6 to the power of 6. And the answer is 2.14, or 2.1 times 10 to the negative 5. 2.1 times 10 to the negative 5. Let me write it. 2.1 times 10 to the negative 5. It means that to write it as a number, this decimal point has to move 5 spaces to the left. So let's do that. 2, 1. It was here. Okay, so we have 1, 2, 3, 4, 5. It's going to be right here. And then we fill up this with zeros. And this is our number. It's not even, it's a very, very small number. The percent is here, the hundredth. Okay, the thousandth is the per mil. It's very, very small number. For the, what is the small number? For the die to show the number 6 times. Okay, there is a very, very low chance. So probably 5 will be 2% or so. Okay, 5 will fill up that missing 2%, and this is almost nothing, so I don't even count it in my calculations. So basically, this is the solution to the question that you have right here. Next question. According to basketballreference.com, the stats of LeBron James' free throw success rate for the season of 2019-2020 is 69.3%. I rounded it to 69 just to make it an easier problem. And this is our question. What is the probability that he will score 3 out of 3 throws? He will score all of them. Okay, the second question is none of the 3 throws. And the third is at least 2 out of the 3. So let's see, 3 out of out of 3 throws, it means P of 3. But before that, let's write the givens. So we have 3 trials, n equals 3. The probability of success is 69%, 0.69. The probability of failure is 1 minus 0.69, which is 0.31. And then here x equals 3. Okay, so number 1, 3 out of 3. Okay, this equals to 3C3. Then we have probability of success, which is 0.69 to the power of x, which is 3. And then we have 0.31 to the power of n minus x, which is 0. So once again, a number to the power of 0 is 1. I'm going to ignore that part. If we have NCN, the number C and the same number, the probability is also, the result is also 1. So I'm going to cancel this as well. And now we have to calculate 0.69 to the power of 3. So 0.69 to the power of 3. This is 0.33. I round it again. 0.33, or also 33%. There is a chance or probability of 33% that LeBron James on a free throw will score 3 out of 3. Number 2 is none of the 3 throws. So here x equals to 0. And P0 equals C3 trials, 0 successes. And then his probability for success. This is to the power of x, so it's 0. And then we have times 0.31 to the power of 3. Now, let's look at this expression, and I'll show it to you by the expression with the factorial that we know. We have n factorial divided by x factorial times n minus x factorial. And I just want to remind you that 0 factorial equals 1, okay, by definition. So n is 3. We have 3 trials, 3 factorial, 0 factorial, times 3 minus 0, which is 3 factorial. This is 1, this cancels out. So the whole thing's here, the whole thing is 1, this is 1, and all we have to calculate is this part, which is 0.31 to the power of 3, and we get 0.03 if I round it. So this will be 0.03 or 3%. So there is only a chance or a probability of 3% that he will miss all 3 throws, free throws. The last one is at least 2 out of 3. What does it mean at least 2? It means 2 or 3. So we need to take P2 and add it to P3. We already know P3, so all we have to do is calculate P2. And let's do that. P2 equals 3C2 times 0.69 to the power of x, and x now is 2, times 0.31 to the power of n minus x, 3 minus 2, which is 1. Okay, calculator, 3, math, probability, 2, exit, 0.69 to the power of 2, exit, and 0.31. I don't need to do to the power of 1. That's it. So to the power of 1 is just the number itself, and enter. So we have 44. Let's get back here. 0.44. Or 44%. So this is it. If you have any questions, you can send me an email or you can write anything in the comments to this video. Thank you for watching, and I'll see you again in the next video. Goodbye.